So let us try to solve this problem here. I have to check whether this is reflexive, the relation are reflexive, symmetric, and transitive. And the set A, which is given 1, 2, 3 to 14, right? And which is defined as R is x comma y such that 3x minus y is equal to 0. So let us start. So given that set A consists of 14 elements, 1 to 14, and the relation R, which is x comma y, the ordered pair, is 3x minus y is equal to 0. Now, let us write down R here. So when x is equal to 1, so you get 3. So it is 1 comma 3 here. Okay, so when x is equal to 2, you get 6. Okay, and this is 3 and 9, right? And 4 comma 12. So this is the relations which we get here. Now under this relation, we got to check whether it is a reflexive, symmetric, or transitive. Okay, so first let me write down whether it is a reflexive or not. So reflexive. Okay, so reflexive is that uh, again you can see here 1 comma 1 or 2 comma 2 or 14 comma 14. Okay, these elements does not belongs to R. So therefore we can say that R is not reflexive. Okay, now let us see whether this is symmetric or not. So let us see whether it is symmetric or not. So let me take any one of the pair here. If I take 1 comma 3, so this belongs to R. As you can see that this is under the relation which is R. But if you look at 3 comma 1, okay, so that does not belongs to R. That is if I substituted 3 multiplied 3 minus 1, so which results to 8, which is not equal to 0. So therefore it is, that is R is not reflexive, not symmetric. Okay, R is not symmetric. Okay. Okay, now let us check whether it is transitive or not. Okay, so for transitive, let me take 1 comma 3, which belongs to R, and I can take 3 comma 9, which also belongs to R. But you can see that here 1 comma 9 does not belongs to R. So that is, so if I put here as 3 into 1, right, minus 9, so which results to minus 6, which is not equal to 0. So therefore can say that R is not transitive. Okay, so hence we can say that R is neither reflexive nor symmetric and nor transitive. Okay, not transitive, not transitive. Now let us check this. The relation in the set n of natural numbers defined as r x comma y, where y is equal to x plus y and x is less than 4. Okay, is a reflexive, symmetric, or transitive. So let us see that as the solution for this is again the set A. You have here A, which is 1, 3, and 13 and 14 to 14, and the relation R, this. So hence R would be when x is equal to 1, y will be 6, 1 comma 6, 2 comma 7, and 3 comma 8. This is the relation which we get. Okay. So as you can see here, less than 4, right? So the condition also. So you got the values which is less than 4, right? So you got 3 comma 8 to the end. Now let us check whether it is reflexive, symmetric, or transitive. So for reflexive, as you can see here, it is clear that 1 comma 1 or 2 comma 2 or take 3 comma 3, okay, that all does not belongs to R. So therefore we can say that R is not reflexive. Okay, so R is not reflexive. Now for symmetric, right? As I can take my new element here, so 1 comma 6, I can see that this belongs to R, but as 6 comma 1, so this does not belongs to R. Therefore, R is not symmetric. Okay. Now let us look whether it is transitive or not. So since as you can see, no pair in this uh, is in R, such that you can say that since no pair in R, such that x comma y and y comma z belongs to R, then x comma z does not belongs to R. So therefore R is not transitive. Okay. So R is not transitive. So hence we can conclude that R is neither reflexive nor symmetric nor transitive.